Could Proxima b be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life on other planets is something that humans are fascinated with. There have been various speculations, and the fact that there have been signals coming from Proxima b makes people believe there is more to it. Despite all these signs, we have yet to determine if these are messages from the planet or just echoes of our own scientists' signals. Often, these signals end up as echoes. In finding out whether these signals are truly from Proxima b, scientists hope to determine if alien life exists. Recently, the James Webb Telescope detected artificial lights on Proxima. If you're interested in learning about other planets and our progress in finding alternate life, subscribe to our channel. We make content about outer space and talk about innovations in science. If you like this content, comment below and share this video with your friends. Now, let's go back into our video. Proxima Centauri, about 4.2 light-years from our solar system, is a faint dwarf star classified as GZ. Thus, the star is known as Proxima Centauri. The star is the closest to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603. The name came from the star's ascension at noon, while several celestial bodies, like the Moon and the Sun, were in a straight line. Proxima Centauri is also known as Alpha Centauri A or Alpha Centauri. It is a single star system with 4 main stars in a line. The idea, Proxima Centauri, is at the center of this system. Apart from the 4 stars, there are 2 faint dwarfs, Alpha Centauri, also called Riddle Chorus, and Alpha Centauri b. These make up the bulk of the mass but are too faint to be seen by the naked eye. The system is located 23 degrees away from the border of the famous Plough asterism in the constellation of Centaurus. Even though Proxima b is a rocky planet, there is still hope that it might have extraterrestrial life. The search for any other life out there has brought scientists to Proxima b. They believe the similarities to Earth's size and the distance it is from its dwarf star make it a viable option when it comes to planets that can accommodate life. While all these are speculations, there's hope there might be some truth. There is much to learn about Proxima b and the orbit it takes, so stay tuned and find out. You can also check out some of our other content related to extraterrestrials. Do you really believe there's another life out there? Leave a comment down below. What fascinates most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star. Its mass is considered to be 1.27 times that of Earth. Besides, Proxima b takes 11.5 days to complete an orbit of its star. It was discovered in 2016, and many scientists are looking into it. Even though Proxima b looks similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star. As such, it keeps getting extreme ultraviolet radiation from the star. It is estimated to be hundreds of times more than the radiation we get from the Sun. The radiation is so strong that it strips away even the lightest hydrogen molecules. Over time, it does the same to oxygen and nitrogen. While most people might argue that Proxima b should be habitable because it is also the same distance from its star as Earth is from the Sun, there is more to it than meets the eye. Distance does not consider whether there is water on the planet. There is also no evidence of an atmosphere conducive to living things. The atmosphere on Earth is what makes it habitable and not Mars. The right atmosphere makes it possible for climate regulation and a water-friendly surface. It also shields living organisms from hazardous space weather. If you're with us so far and have not subscribed yet, take a second to hit the subscribe button. It makes it easy for us to keep creating content like this that you'll love. Now let's look at why people think that the James Webb Telescope will help us figure out if there is life on Proxima b. The James Webb Telescope was launched in 2018 after being delayed since 2011. Many changes had to be made to ensure it gave accurate images during production. Loeb explained that if a planet like Proxima b could absorb light from its star, it could also re-emit it as infrared light. The James Webb Telescope was explicitly invented to observe infrared light. It can take photos of this light on the surface of a planet and look for patterns that might confirm if the planet has water or an atmosphere. One of the reasons why space telescopes are preferred over ground-based ones is that by being above the atmosphere, they don't have to peer through the shifting air to see deep into space. Therefore, they get a better view of what goes on outside the solar system than most ground telescopes can achieve. The other advantage they come with is that weather changes on Earth do not affect them, and astronomers can be sure they're getting a clear reading. The only downside to having a space telescope is that fixing it is expensive. If something goes wrong, there have been cases where a small flaw in a space telescope requires a whole mission into space to fix it. Such costs make observing planets like Proxima be difficult. With the James Webb Telescope, we have no option for rescue. It has been launched over 1.5 million kilometers away, further than any human has ever traveled, so rescue missions are not an option. The James Webb Telescope comes with a larger mirror. Because of that, we can see way back to the beginning of the universe, almost 13.7 billion years ago. The further away an object is, the further in time we get to see it. The reason for this is that it takes a while for the light to travel from an object back to us. The ability of the James Webb Space Telescope to see the universe in a longer wavelength in infrared light means we get to see more distant galaxies in our universe with more certainty than was previously possible. Therefore, observing planets like Proxima b has become easier, and it has pushed the light out of the visible range and into the infrared. Tabor and Loeb have a scale of artificial illumination as a fraction of how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, one would assume that the planet's night side is completely dark with no illumination. At 100%, it means that the planet's night side is just as bright as the day side. There has been a hypothetical civilization on Proxima b using this type of light, and most scientists believe it is similar to the early days on Earth. The studies show that if the night side of Proxima b reaches an illumination of 5% of the natural day side, then the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Even though 5% illumination sounds like a small number, we're talking about the light from a star as far as Proxima Centauri is compared to our sun. We have an illumination that is 20,000 times dimmer, yet we still have a lot of light from our star. This basically means that at 0.1% of illumination, we are still reflected in the stellar illumination. In other words, if Proxima b has any civilization in disguise glowing like Earth, the James Webb Telescope would not detect it. The stars would need to be about 500 times brighter. This scenario is impossible since Proxima b orbits so closely to its host star. There is a chance that it might be tidally locked, meaning one side of the planet always faces the star, while the other is in perpetual night. A civilization living on a tidally locked planet might need to focus on illuminating infrastructure and use very bright orbital mirrors to reflect sunlight from the day side to the night side of the planet. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that it is true. The Earth's illumination can be seen from outer space and is known as airglow. Most people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. The airglow happens when atoms and molecules in the upper atmosphere produce light to release excess energy. On Earth, the airglow can happen when atoms and molecules get ionized by sunlight and capture free electrons. The glow seems similar to an aurora, except that auroras are driven by high-energy particles from the solar wind. The airglow is driven daily by solar radiation. Since the James Webb Space Telescope's launch, scientists have been asking whether it is sufficient to view other planets in faraway galaxies. Even though it is the furthest satellite telescope launched, it still provides very little data needed to find planets with life in other galaxies. As such, there have been conversations about developing bigger and better telescopes. These ventures are often costly and involve a lot of trial and error. The James Webb Space Telescope's launch was 5 years late due to these issues. Therefore, it is challenging for most scientists to develop better innovations that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising. Soon, we might know if there is life on Proxima b and other planets. While work is still being done on more telescopes, it is believed that the completion and launch of the habitable exoplanet observatory will revolutionize planetary research. Another new telescope project, HabEx, aims to help scientists study planets in even more detail. It is being developed to study the atmospheres and detect life. HabEx will observe any potential life signs from planets like Proxima b. HabEx is scheduled for 2035, which marks an interesting point in space exploration. Another telescope, the Lewis telescope, is being developed to complement the Hubble and James Webb telescope. This smaller observatory will focus on ultraviolet light. Studies of Earth-like planets have also shown promising results. However, our knowledge of planets like Proxima b will continue to grow as we develop new telescopes. Stay with us for further updates. To further explore the possibilities of life on planets like Proxima b, scientists are continuously improving their technology and methods for studying distant worlds. As mentioned earlier, the James Webb Space Telescope, JWST, has made significant strides in enhancing our ability to observe planets outside our solar system, but it's not the only tool in the arsenal of space researchers. The upcoming launch of other telescopes like the Habitable Exoplanet Observatory and LUVOIR, Large UV/Optical Infrared Surveyor, promises to push our understanding even further, allowing us to answer questions that have eluded scientists for decades. The need for advanced space telescopes. One of the biggest challenges when searching for extraterrestrial life is the limitations of current technology. Ground-based telescopes, although powerful, are subject to atmospheric interference, such as clouds and air turbulence, which makes it difficult to get clear, accurate data on distant planets. Space telescopes like the JWST bypass these issues by being placed beyond Earth's atmosphere. However, as groundbreaking as the JWST is, it still has its limitations in terms of resolution and wavelength sensitivity. This is where next-generation telescopes come into play. The Habitable Exoplanet Observatory (HABEX) is expected to have a much larger mirror and superior infrared sensitivity compared to current space telescopes, which will allow scientists to study the atmospheres of exoplanets in more detail. HABEX will be equipped to search for biosignatures and trace gases in the atmospheres of planets in the habitable zone, the region around a star where conditions may be right for liquid water to exist. HABEX's ability to observe in the ultraviolet and optical bands will also enhance its ability to detect signs of biological activity, such as oxygen, methane, and ozone, which are potential indicators of life. Meanwhile, LUVOIR, another space telescope concept, is designed to observe distant exoplanets with unprecedented clarity. LUVOIR's ability to capture high-resolution images of exoplanets in the visible, ultraviolet, and infrared spectra will allow researchers to study their atmospheres and surface conditions in greater detail. The telescope's enormous aperture, larger than the JWST, will help it achieve incredible resolution, enabling scientists to observe distant planets as if they were much closer to Earth. Challenges in detecting life. The search for extraterrestrial life hinges not only on detecting planets that could support life, but also on identifying signs of life. Although the existence of Earth-like planets in habitable zones is exciting, detecting life beyond Earth remains a massive challenge. Scientists have to account for the many variables that make a planet capable of sustaining life, such as the planet's size, composition, distance from its star, the nature of its atmosphere, and its magnetic field. Even if a planet is in the habitable zone, other factors such as radiation levels, atmospheric composition, and the presence of liquid water are crucial for life to thrive. For instance, even though Proxima b has been identified as being in the habitable zone of its star, it faces harsh conditions that could make it uninhabitable. The planet is exposed to intense radiation from its parent star, which could strip away its atmosphere and create a hostile environment. In addition, Proxima b's proximity to its star raises the possibility that it is tidally locked, meaning one side always faces the star while the other side remains in perpetual darkness. This could lead to extreme temperature differences and challenges for any life forms that might exist there. The role of artificial intelligence in planetary exploration. As space telescopes become more advanced, the role of artificial intelligence, AI, in analyzing the vast amounts of data generated by these instruments is becoming increasingly important. The sheer volume of data from telescopes like the JWST can be overwhelming, and AI is being used to help sort through this data and identify potential signs of life. For example, AI algorithms are being trained to recognize patterns in light curves, spectroscopic data, and images of exoplanets that could indicate the presence of water, oxygen, or other biomarkers associated with life. This technology will help scientists prioritize which planets to study further and make discoveries more efficiently. AI can also aid in the development of new instruments and techniques for planetary exploration. By simulating different scenarios and modeling various planetary environments, AI can help scientists predict what kind of data to look for when observing distant planets. This will be especially useful as space missions become more ambitious and aim to explore planets in greater detail than ever before. The long-term future of extraterrestrial life research. Looking further into the future, the next few decades could see even more breakthroughs in the search for life beyond Earth. While the development of space telescopes like HABEX and LUVOIR will undoubtedly enhance our understanding of distant exoplanets, the next big step could involve sending probes or even crewed missions to other star systems. These missions would aim to study planets up close and gather more direct data about their composition, atmospheres, and potential for habitability. One of the most ambitious plans on the horizon is the idea of sending a probe to Alpha Centauri, the closest star system to Earth, which is home to Proxima Centauri. Various projects, such as the Breakthrough Starshot Initiative, aim to develop small, fast spacecraft capable of reaching Alpha Centauri within a few decades. These missions would be equipped with advanced sensors to detect signs of life, study the characteristics of exoplanets like Proxima b, and even send back real-time data from another star system. While these long-term plans are still in their early stages, the development of new technologies and international collaboration in space exploration offers hope for discovering extraterrestrial life in the not-so-distant future. With continued advancements in both observational tools and scientific understanding, the search for life beyond Earth will undoubtedly enter an exciting new era in the coming decades. As we continue to look outward to the stars, the fascination with Proxima b and other distant worlds reminds us that we are not only seeking answers about the universe but also about our place in it. Whether Proxima b hosts life or not, the journey of discovery will undoubtedly expand our knowledge of the cosmos and deepen our understanding of the potential for life elsewhere in the universe.